Hi. So in this problem, we are going to look at a geometry question where we have a quadrilateral ABCD. It's a convex quadrilateral, and on the segments AB, BC, CD, and DA, we have chosen 4 points M, N, P, and Q. Okay. Now the condition of the question is saying that AQ is equal to DP is equal to CN is equal to BM. Right. So let's label these distances AQ, this distance is X, let's say, then DP is also X, and CN is also X, and BM is also X, right? These distances are X. Now the question says that if MNPQ is a square, then we have to show that ABCD will also be a square, right? If this quadrilateral inside MNPQ is a square, so I have already marked it like that. I have said that these sides are equal, and I'm assuming that MNPQ is a square, and all these angles are 90 degrees, right? And then we have to prove that ABCD is also a square, correct? Let's see how we approach this problem. So we have already marked BM, AQ, DP, and CN as X. Let's also assume that MN, the distance of this side, is U. So we are saying MN is U. And let's say that AB overall, the whole length of AB is A, right? Overall length of AB is A. Okay. So if AB is A, then obviously AM will be A minus X, right? This becomes A minus X. And let's also assume that angle PQD is equal to alpha. PQD is this angle, PQD. So this angle becomes alpha. And we have angle MQA. MQA should be 90 minus alpha. Why? Because the whole angle MQA plus MQP plus PQD should add up to 180. And we know that MQP is a 90 degree here because we have assumed that MNPQ is a square. Therefore, we can say that angle MQA is equal to 90 minus alpha, right? Great. So now I want to make a conclusion about the overall quadrilateral. So I have to get a sense of the angles and the sides of the overall quadrilateral, right? So what we'll do is we'll look at triangles here. For example, triangle PQD, right? And we'll apply sine rule and cosine rules in these triangles. So let's see what comes from there. Triangle PQD, if you do sine rule, we get x by sine alpha, x by sine alpha is equal to u, because this side will also be u. It will be u by sine angle d, u by sine d, right? Because this side is, why is this side u? Because we have assumed MNPQ is a square and MN was u, right? So this is x by sine alpha is u by sine d from sine rule, and therefore we can write sine alpha as basically x sine d by u, right? This is our sine alpha, correct? This is relation 1. And then we look at triangle AMQ. Triangle AMQ, and we look at cosine rule here. So we say cos of MQA. MQA angle is 90 minus alpha. So cos of MQA will be actually sine alpha. So sine alpha is coming out to be equal to AQ square, which is x square, plus u square minus AM square, which is A minus x whole square, divided by 2xu, right? So from here, what we get is a condition. So we get 2xu sine alpha. 2xu sine alpha is equal to basically AQ square. So that is x square plus u square minus A minus x whole square. This is the second result. This is the first result. Okay. We have applied cosine rule in triangle AMQ. And now we will do cosine rule in triangle AMQ, but again, now we'll do it for angle A, this angle, okay? So I'll create some space on top here, and I will say what is cos angle MAQ in the same triangle MAQ, right? So let's see what comes from there. Okay, so this is let's call it angle A. So we say cos of A should be equal to basically A minus x whole square plus x square. A minus x whole square plus x square minus u square by 2a minus x into x, right? Great. So we have here 2a minus x cos a is equal to a minus x whole square plus x square minus u square, right? This is result 3, right? We have result 2 here, where you had, if you notice, x square minus u square here and a minus x square was added. And here it is u square minus a minus x square, right? So if I just isolate a minus x whole square minus u square from 3, I will get that is equal to 2a minus x cos a minus x square, right? And I will write the same thing from here, a minus x whole square minus u square from 2, a minus x whole square minus u square from 2 is equal to basically x square minus 2xu sine alpha, right? That is what we are getting, correct? So now we equate both the things, correct? We can equate both of these terms, right? We are getting the same thing from 2 and the same thing from 3. We equate the left hand sides of both here. What we will end up getting is basically 2a minus x cos a minus x squared is equal to x square minus 2xu sine alpha, right? Okay. So let's bring everything on one side. You get 2x squared is equal to 2a minus x cos a plus 2x u sine alpha, right? Okay. We can cancel 2x from both sides here. If we cancel 2x from both sides, we end up getting x. X is equal to a minus x cos a plus u sine alpha, right? Great. A minus x cos a plus u sine alpha is equal to x, and we can isolate cos a here. We can say x minus u sine alpha by a minus x is equal to cos a, right? We are getting this, correct? So what is u sine alpha? So u sine alpha here will basically become, this quantity is positive, right? This quantity cos a is greater than or equal to 0. Why? Because x is greater than u sine alpha. We have sine alpha is x sine d by u. So if I put that here, I will get x minus u into x sine d by u. That becomes x minus x sine d by a minus x. So that is x into 1 minus sine d by a minus x. And this is completely positive. Basically, I'm using the first result here and putting it here, right? I'm saying sine alpha is this. And if I put that here, I will get x into 1 minus sine d by a minus x, right? That is equal to cos a. I will write this on the next screen. So I'm getting cos a is equal to x into 1 minus sine d by a minus x. You will realize that this part is positive. This is also positive and x is also positive. So cos a is greater than or equal to 0 is coming, right? If cos a is greater than or equal to 0, angle A is less than or equal to 90 degrees, right? And the analysis here was completely general. This is true for, you can repeat the same analysis by taking similar triangles and you can prove that B is less than or equal to 90, C is less than or equal to 90, and D is less than or equal to 90. Since all the angles are coming and you're getting results like this, it cannot be true that all the angles can be less than 90 because the overall sum of all the angles must be 360 degree, right? So therefore, this implies itself that A is equal to B is equal to C is equal to D is equal to 90 degree. And that means ABCD is a square. How are we able to say that it's a square? Because we got cos A as this, which was positive, which means every angle must be less than 90, but that is not possible for a quadrilateral. And therefore, we are implying that A and B and C and D are all equal to 90 degrees. And therefore, ABCD is a square. I hope you got the solution. If anybody has any doubts in this, you can just message, comment on the section, and I will try and explain it in a little more detail in the next video. That's it for this one.